Hello.
Yeah, you're audible.
Yeah. So, hello everyone. Welcome to another session of Introduction to Machine Learning. And in today's session, I'll be dealing with unsupervised and supervised classifier that is mostly of clustering that is called KNN, that is K nearest neighbors. And let me know if there is any fluctuation in internet or any connectivity issue in between. Okay.
No, ma'am. Everything is fine, ma'am.
Okay. So I'll start with the lecture. I'll share my screen. I hope my screen is visible. I'll share the Google Colab link. Okay. So for today's class, we'll be dealing with K nearest neighbor, that is KNN algorithm. So it is one of the algorithm that can be used both for classification and regression, right? So what does this term K means in this K nearest neighbor? So can anyone tell me like what is KNN? Do you guys have read about it in your theory lectures? If no, then I can explain it in little more detail. If yes, then I can take it like for the programming part. So please let me know. Hello. Uh, I'm audible, right? Okay.
Yes, ma'am. Before classification, we need to set the how many classes are required.
Okay. So okay, in all the like all the machine learning algorithm, we used to find like if there are different classes, and if another class has been there, so we need to find which class this belong to. That is what KNN does as well. Okay. For example, I'd like to give this as an example with this diagram. So consider this red one as class 1 and the green triangle as class B. Now suppose we have an example and we don't know which this class will belong to, which class this it will belong to. With KNN, we try to calculate with the nearest neighbor, and the term k over tells the nearest number of nearest neighbors. Okay. So for example, if I'll take k is equals to 3 as shown in this example, so the nearest three classes of all the class. So basically these classes are in cluster form. What does cluster mean? For example, um if a class belong to grass or a water body. Okay, I'll talk about in terms of pixels, I'll talk about in terms of images. So suppose you have an image in which there are two classes. One is your water body and one is your land. Okay. So water bodies will be having some pixels and it belong to a certain class. So suppose water body belongs to class A and land belongs to class B. Now if I have a pixel which you don't know which class it belongs to, okay, so how do you calculate it? So for that, what we do is we calculate the nearest three pixels values of that class, if we are considering k is equals to 3. Similarly, if we are increasing the k value, that is how we are taking it. So for over in this example, we have taken the k is equals to 3. So this yellow question mark is the class. We don't know which class it belongs to. So for the nearby three classes, we are calculating its distance for the red one, and the nearby distance we are calculating for the green one. And how we are going to choose it, which class does it belong to? The least number, the least mean value which it will belong to, sorry, will be given to class B. For example, if like for example, if we have calculated k is equals to 3, and in the circle you can see the red one belong, just one class came into that, while the green one come into two of the values. So we will be giving this unknown to class B. Okay. But this can this is not a very good method. Why? Because for example, if I'll increase my k value, if I'll take, instead of 3, I'll take k is equals to 7, then a bigger circle can come in, and then there may be chances that instead of green, the class will belong to red, because it is more of like, voting kind of thing. It's more of like if we are calculating the distance or mean distance or whatever the distance value, and whichever the class which is having the maximum number of that distance value, we are giving that unknown class to that class. But that doesn't mean that it is how it is done, and that is why KNN is also called a lazy method. So we usually don't prefer, but it's a very good method when we don't have label information, or when there is unsupervised information in the terms of that. Okay. So getting into that, over here there are three things today I'll be dealing with. First, I'll be creating one a very like normal data set which we have just created, and we can see how things work. Secondly, again, I'll take a larger data set. And thirdly, a very important question in KNN is that how you should decide the value of k. What should be the ideal value of k, or the optimized? I should not say the ideal, because ideal is something that never exists. So, what should be the optimized value of k? How do you decide it? Okay, so we can do that using coding as well. And that k value, I'm not talking about for the smaller data set. That k value is important when we have a very huge data set. So how you are going to find the value of k when we have a huge data set, and when we have to relate it with accuracy and error rate, because that is how we evaluate our model, that my model is working fine, my model is how my model is, right? So let's begin with the very basic data set. So suppose we have to like tell a kid that you can go for play or you cannot go for play. So there are some conditions for that, and those conditions we defined it in terms of weather and temperature. So what I'm saying is, if it is sunny and hot, then you should not go for play. Similarly, if it is sunny and hot, again you should not go. But yeah, if it is overcast and hot, you can go for play. You can go out to play. Similarly, if it is rainy and mild, so there are two things, two classes. One is weather, one is temperature. On the basis of that, I'm giving a what output value. So this is my data set. This is just what we have created. Okay, this is some particular data set, a handful of data set. How things will work with that. Okay. Similarly, okay, I'll simultaneously I'll run the programs. I hope there will be no error. Yeah. Okay. So my data set has been loaded. Again, we cannot, our system, our machine doesn't understand this, terms as sunny, overcast, you should go for play or not. No. It always understand terms in the form of digits or numbers or binary. So what we have to do is we have to encode it. So what I'm doing is I'm encoding my data, that is overcast as 0, rainy as 1, sunny as 2. Okay. So first this thing I have done, I'm encoding my weather data. Similarly, I'll also encode my temperature and play data, because that is how we will know the output. We have to assign some encoding language, some coding. Okay, if 0 is coming, that it means overcast. Okay. So to do that, I'm importing pre-processing. There's something called label encoder, which we have already done previously, right? So that is encoding the labels, and we are converting the strings into numbers. So doing that, oh, in this I have just shown you how we can do the encoding of weather, and I have printed the weather encoded. So now you can see this 2201. Like just take the 2201, which means 2 is for sunny, overcast, rainy. So this is how it is done. Okay. Similarly, I need to do for my temperature and play as well. The encoding part I did for that as well. So for temperature, again, I did whatever it is. For play, 0 and 1. 0 means you cannot go to play. 1 is you can go for play. Okay. Now I'll be like, what is my two data set that I need to work to get my output. So two data set is my weather and temperature, right? And based on this data set, I'll be getting my output in terms of play. You should go to play or not. So I'm just like making a list of it. I'm combining this weather and temperature. That's it. Nothing much. Okay. Now the thing comes. Now I have to call K neighbors. K nearest neighbor. That is KNN. So I told you this sklearn. Sklearn is a wonderful library. You can find all the machine learning algorithms and libraries into that. That will ease your work. So sklearn.neighbors. I'm importing my K neighbors classifiers. Okay. I am taking KNN value as 3. Again, how should I decide it 3? That depends on so many factors. Over here I'm taking 3. Why? Because my data set is very small. We can, and in the end I'll tell you what is how you should decide the value of K. Okay. Now I'm training my model using the train sets. So this is that model.fit features. What were the features? My weather and temperature. What was my label? My plaything, which is needed to be play. Okay. Now I'm going to predict my output. And this is very small data set. I just wanted to show you how things can be done. So, till here, train the model using the training set. This is till here, model.fit. My data set has been trained. That's it. End of my model, training model. Now that is not where we need to stop, right? We need to see if I'm giving some random numbers or some random input, if it is able to predict the output or not with some numbers that has not been already put in as data. So what I'm doing for predicting, I'm taking 0 and 2. 0 is my overcast was what? Weather. And 2 is for my mild is what? My temperature. So there were two features, right? Weather and temperature. So 0 is for weather and 2 is for temperature. And I need to predict the play part, right? So what will be my output? So running this, my output is coming as 1. 1 means you can go for play. Similarly, you can change it anything. You can just keep it as 1 and I'll keep it as again 1. Okay. So that can be, I don't remember. I have to check what was 1 and 1. So if we'll go back, we'll check what did we assign for 1. 1 was rainy. Okay. And again 1 was, there were 3 options, right? Hot, mild and cool. So again 1 was my for mild. So we can see what will be the output. That's again we can predict. It came 0. This means you cannot go for output. You cannot go to play. Similarly, we can just play around with it. This is one thing which, see, again it came. You can go for play. Okay, so this is one example. Now I just wanted to show how my KNN works. So the right now I just took two features and there was one label. Okay, you can just you can actually know what should be your predicted output. Now I will be taking a huge data set, a data set which has like a more number of data set and how the things will work. So like there's so many data sets, and again I'll randomly I am choosing one kind of data set which can work with this. So with the data set which I just showed you, there were two classes, weather and temperature. It was pretty much easy to call, to do everything. Now what if I have a like huge raw data set? What are the features we need to decide, and how we are going to decide it, and what should be the output, and etc etc etc, right? So first, let's call our again the packages. And again, I'm telling you, it's not that I knew already these are the packages that is going to use it. That is going to be used in this coding. No, I just knew one package before starting this. That is my NP, because I needed to call my data, and similarly pandas because I needed to create a data frame out of my raw data. So these are few things which I already knew. All other libraries I kept in adding, and I like keep adding it at one common cell, that so that it will be convenient for me itself. Okay. So I am taking one data set which is called fruit data with colors. So what it does is it has different kinds of fruit label, which tells it has four kind of different fruits, and with the help of its fruit subtype, its mass, width, height, color score, etc., it tells which kind of fruit it is. And that fruit name is given as 1, 2, 3, etc. So what I'm saying is, if it is coming 1, that it means apple. If it is coming 2, that it means mandarin. 3, orange. 4, lemon. So there are 4 classes. And what are our features? Features are our its mass, width, height, and color scale. On the basis of that, I'm going to define which kind of fruit it is. Okay, this is what my example is. All right. So I am calling my data set. I am again converting my data set into what? Data frame. I'm defining what my x should be. I'm so sorry. What my features should be. The features should, I have written feature names fruits, and what my output should be. Okay. So the top 10, like the I just needed to see what all different kinds of values the data have. That's it. Now I need to do that, what I taught, what it is called feature engineering, or you can refine it as EDA, or whatever you want to say. You want to give what are all the features you need to give for x and y, that is your input and output. That's it. So what I did is, on the basis of the data given provided, its height and width, I wanted to know what kind of fruit it is. That is what my idea is. So I am going to take the height and width from the data, and on the basis of it, I am going to define what kind of fruit it is. Okay. So x is my variable and y should be my output, that is label. Okay. So yeah, again, I did that. Now I need to split my data into 70 25, 70 30, or 75 25, whatever ratio you want. So I'm again splitting my data into train and test, right? Doing that. And again, next thing, the height and width, if you will see this height and width, these are in terms of what? Numerical numbers, right? Fruit name is in terms of what? Strings. Or fruit level, if you talk about it is in terms of integers. So there are two different kinds of data types. You cannot handle two different kinds of data. It's very similar to how we do in mathematics. Like we cannot add two different kinds of data, right? Like we cannot add not, I should not say add, uh, like if we need to subtract two different kinds of data, we cannot do that, right? Or I should say in a very simple, you can compare apple with apple, not apple with oranges. So something like this. Okay. So we need to keep it at a common platform, okay, at a common range. And we have to do it. See, the steps after feature engineering or data engineering, it's almost the same. Calling your data, fitting your data, scaling your data, normalizing your data, and again splitting it into training and test, and fitting your data and running your model and predicting the data. That's it. It's almost similar. So again, I'm scaling the my training data. I'm using that scalar.fit transform, and again I'm scaling my test data. Okay. Now I have to call my KNN model. I will be calling KNN, K nearest neighbors, which I've already like if you'll see in this cell, which I have already called over here from sklearn.neighbors import K neighbors classifiers. I've already called my KNN. So over here I'll be fitting my data, and over here I've taken KNN value, K value as 5. Again, there's no compulsion what value you should take. It depends on how your error rate is working, or how your accuracy is working. So this KNN values, in KNN the K values depends on your accuracy and your error rate. And we'll see how we decide it. Okay, I'll give you one example for that as well. So K nearest neighbor, n neighbor is equals to 5. We are fitting it. And yes, my K neighbor is again called. Now I need to find my accuracy for KNN. Okay, there is something called score, KNN dot score. I'm calling my train scale data, y train data. Okay, and this is nothing. This is something you can remove it. There's just don't go with this thing. This is something I have just written as train said, because okay, you can remove this. Again, this is not important at all. So just I am calculating my KNN for the training and testing data. That's it. And how we are going to do is there's something called score. And again, this score dot score is already been used. And how I'm using this KNN shortcut, because I have called my KNN is equals to K neighbor classifiers. Okay. Over here I have given K neighbor classifier as KNN. So when I'm running this, I'll be getting the accuracy for KNN training set and test set. Okay, why I'm not getting the, okay, I have just done the printing and there's some error in that. Oh, just a minute. One thing, I don't know, it should, it, just a minute. Score is equals to, let's do, it should be, the value is not coming, KNN score. X train, Y train, okay. Print score. Let's do print score. Okay. Yeah. Let me run this. Let me see if this is giving me score. Yes. So this was the problem. Did you see like this format is not working? So this is so you can see for training I will just write it as score train. Okay. And print score train. Sorry. Yeah. Score train and let's do this. We don't need this because it is not giving any information, it is just printing this and there was some error in that, so I'll just write it here. Okay, yeah, so let's keep it here. Yes, now it will print, right? Similarly I have to do this for my, I don't need this thing, I can just remove it. Okay. Did you understand? Like it was just giving the printing the testing and accuracy. It was not giving the actual value. So we needed value, right? So we need value. What has to be printed, not just this thing. So let's write score test. Okay. Score test is equals to KNN dot score x test scale y test, right? And now I'll print this again. So yeah, let's do this. So accuracy of Kenning on test set. Okay. And instead of this, I'll write test. Now, hopefully I'll get the result. Yeah. So let's do this. Now see, for training, I'm getting 0.95 and for test data, it's 1. Okay. So this means for testing, whatever the values it's taking, it is giving a good result. And it's actually like a not a it's feasible for test data, because why it is giving one, that is 100% accuracy for test data, because the training which has already been done on the training set data, that has been tested on the test data. So it will always, for example, the model already know that this is the this is this fruit, or this is this data set, because it has already been trained. So this 95% is accuracy what we should look for, not the test data. Okay. Okay. So now I need to, I'm like my, I have called the data set, I have scaled the data set at one particular level. I called my classifier, that is KNN. I fitted the classifier. I trained my model, splitting it into training and testing. I calculated the accuracy of it, and my training accuracy was 95%, which is pretty much good. Now I need to do a prediction, obviously, because what we are doing is with terms of, if we look at the data set, we'll go back to the data set again. So with the term, with the help of its mass, width, height and color score, we are finding what kind of fruit it is. We need, my data is trained with this, like what are the features names I provided, height, width, mass and color score. With the help of this, I was predicting my fruit labels. This, so 1 is my apple, again remember that, 2 is mandarin, 3 is orange, 4 is lemon, something like this we were doing, right? Now I need to predict it. So random something number I took 5.5 for fruit mass, 2.2 for width, height 10 and color score 0.70. Again, this is something which I took. You can take any number. We'll change it and we'll see what how my results is varying. We'll go for that also. Okay. And I'm again scaling it. because I need to scale it, because if I need to calculate it between zero, value between 1, 2, 3, 4, something like this, right? That is how it will give, right? Now I'm doing the prediction, predicted fruit type, example fruit, and what I'm doing is you have to predict the example fruit scaled, this example fruit scaled between 0 to 1. So if it is, why it is 0 minus 1? See, usually if you go back to the previous example, the first class I gave it as 0, but in this the first class I'm giving it as 1. So in machine learning, by default everything starts with 0. So this time I'm not doing that. That is why I have to do 0 minus 1. That is, you have to start with 1. So whatever the value is 1 is, it will be considered as that value. Or whatever is 2 is, it will be considered as that value. So if I'll run, I'm giving this is a mandarin. So this mass, height, width, height, and color score. If this is that, it will be a mandarin. Let's change it. If someone want to give any example, tell me. I'll do that, and we'll check the result. Tell me if you want to have some particular value. Do anyone want to give some particular value and want to check? Sorry, I'm not able to hear you. 7.6. Okay. 7.6. Then, okay, let's do it. 3.4. This 10 was height. So let's reduce the height. I don't know what it can be. 8. And again, I'll reduce the score. Let's see. We are just checking around, right? See, now with the help of this data set, it is coming as 11. So this is just predicting. This is how we do. Like, it means my model is learned with all the data set it has provided, and now you will tell if this is the values, what is the example. It's very similar to how you train a kid. If you are telling it, see, if you have to tell an apple, you have to predict, and like if you train a kid that this is an apple, how you will tell it? If a fruit is round in shape, or if a fruit is some oval in shape and red color and this and that, that is how you have to predict it is an apple. Similar to that, it is how machine learning is. You're giving some information in on it, and on the basis of that, if you get similar features or similar values, it will predict some values. Okay. Now what I've done is I have this will look like a bigger code, but it's nothing a bigger code. I just took so many of libraries and different values and all. I just wanted to show you in terms of decision boundary, or you can say, what if I wanted to show all the four classes in one form. What I meant was, I just wanted to show you how my classes will look in terms of clusters. Like we were having four classes, right? And this is nothing. Don't break your head into this code cell. Sorry, don't break your head into this code cell. This is only and only about visualization. Even if you don't get it, not at all, no issues. It's just I wanted to give a picture of you picture to you how my data sets look. The data set which we have considered look in the form of clusters. Okay, how, what I meant when when I was using the term clusters. So can you see, apple is one cluster, orange, which is represented in blue, is one cluster, mandarin in green, and lemon in gray. Okay, so this is, if now if I have a data set, a very unknown data set which I don't know which class it will belong. For example, if a data set which we don't know how we are going to take, if we are taking k is equals to 5, so it will calculate the distance of five features, nearest five features for every class, not one class. So it will take five from red, five from blue, five from gray, five from green. And how it will decide? After calculating the values, the distance values, the minimum values which is belonging to the most of the class. For example, if values were coming 2.1, 2.2, something like this. So what are the values that is coming maximum for a particular class? That is more of like voting. Okay, so that will belong to that class. So that is why the KNNs are not very much recommendable when we deal with a very sensitive data. Okay. Okay. So till now, do you guys have any question? Please do ask me related to KNN, because the next thing which I'm going to show you is a very small thing which I wanted to show you in terms of accuracy and error rate, how you're going to, find out the value of K. Okay. So usually the K value we go with instinct. We go with, okay, if this is my data set, let's go with K5, K7 and see how my results are coming, and then we can change. It's hit and trial. But there's one thing I came across and I wanted to show you how you can decide the value of K with some examples. So I'll show you. But before that, if you have any doubt, please ask me. Okay, do you have any doubt from do you guys have any question? Please ask me. No, then I can move ahead.
No doubts, ma'am.
Okay. Okay. So this section I'll be dealing with how you can choose the value of K. Okay, and K in KNN is the most important point, most important factor, because of which your whole algorithm or your whole machine learning network which has been trained can be good or can be false. False as in it can predict truly or it can give a false result. Okay, so how we are going to do is I would like to give you with an example. So there's an example called telecustomers. So what does telecustomers have? On the basis of its reasons, okay, on the basis of different reasons, it is giving me tenure, age, marital, like telecustomers, like mostly phone networks. So with the basis of different categories data, it is giving me which region it belongs to. That's it. Okay, so these are the different features which it is. And again, I am calling a library. Okay, so this cussed cat, I don't know what it was and I don't need it, I felt. So I'm just dropping this cussed cat. Okay, I don't need this cussed cat, so I'm exactly dropping this. And what I'm telling is, instead of cussed cat, take all the features, and the cussed cat is my output. Okay, cussed cat means customer service. Okay, so with the tele customer, I'm telling you, with the help of this reason, tenure, age, all these factor, which customer category does it belong to? That is my model is. This cat is nothing but a customer category. That a particular customer belong to which category? There are different categories of that. Let's not we don't need to know what these are. I just wanted to show you how my K values, if we change the values of K or if we change different values of K, how you're going to take it. Okay. So it's similar to, again, I have defined the value of X, that is, except for this, take all the values. I'm defining the value of Y, that this is my output. This is what I need. I'm again calling pre-processing, doing the transformation which is needed, right? Everywhere it is needed. And what I have done, like initially what I was doing was I was converting strings into encoders. Over here, all the values are in like integers only, but one value is in float. This is 64.0. So there is a basic rule for Python. If even one data set is in float, you have to convert all the integer into float. So it means uh, if I have to tell you that you have to add 2.4 plus 2. So how you are going to add? So we usually do like this, right? 2.4 plus 2.0, and then we add, right? 0 have nothing but it's 2 only. 2.0 is nothing but 2 only. Similarly, in machine learning also, integers needed to be converted into float even if one data set is float, and vice versa is no, there's no option. You cannot convert a float into integer. Obviously, no, you cannot convert 2.2 into integer value. It's a float, it's a decimal value. You cannot convert into single digit. Similar to that. So that is why instead of converting into encoders or scaling it into 0 to 1 or minus 1 to 1, I'm converting all the data values into float. Okay, so I'm pre-processing standard scalar and I'm doing the floating. Again, I'm making my model learn. I'm doing the train and test split data. and training, and I'm over here I'm taking test size at 0.2. Test size at 0.2 means 80% of data I'm taking for training and 20% of data I'm taking for testing. Okay, now I'm doing k neighbors classifiers, I'm calling that. These are the basic things which we have already seen. That is not my intention is. Now over here I'm training my model for k is equals to 4. Okay, and I want to see what my accuracy is when I'm taking k is equals to 4. So if I'll run, I've already done this. So my accuracy for accuracy of model at k is equals to 4 is 0.32, which is, I don't know, it's good or not. It's just random number which I wanted to see by taking a number, and what will be the accuracy of that, accuracy of model. What main concern is how we have to define the value of k. So let's get back to very basic, very basic. Okay, any model of machine learning, it is a good model or it is a bad model, is defined just by two factors, only two factors. One is how much accuracy it is giving, the final accurate values it is giving, which means true positive, false positive, what we have seen means if I am going to predict for my data, what is the accuracy of that? What is the chances that it will give a good accuracy? One, the most important one. And second most important is, will my, because see, the ideal condition will be there will be no error, but that is the ideal condition. In real life there will be some error can be with so many factors. So what our job as a machine learner is, or as an analyst is, that we need to reduce the error. Okay, we should minimize the error as much as possible. Okay, we cannot neglect it, we cannot keep it at zero. So we have to see that when the error rate is minimum and when the accuracy is maximum, and that at that point we decide our certain parameter value. Okay, similarly for KNN as well, at what is the value should of the k defines when is the minimum error rate and when is the maximum accuracy. And yes, it is a hit and trial method, or you have to do a recursive things to look for it. But if you want to use KNN for a particular model, and if you want to use like have the maximum accuracy and the least error rate, this is how you can go for it. Otherwise, you can just do a hit and trial method. You can take a random k values and you can see your accuracy. So over here, what I'm doing is I'm defining the value of k in terms of two terms, which we just discussed: error rate and accuracy. So first, let's go with the error rate. So I'm taking the range of 1 to 40. And what is this range? I'm taking the value of k. So if you'll see, for I in the range 1 to 40. Okay, so take the value of k from 1 to 40. Now you have to see, it's a huge data, right? 1, 2, 3, 4. So check the accuracy from all 1 to 40. Now I take the k neighbors. I am fitting again this again the fitting thing extrain, and now you have to predict my data on the x test. And this append means you have to append all the results by taking the mean of this into this error rate. And instead of just for the values, because values will be a huge numbers which you will not be able to get it, i'm uh, I am visualizing you in terms of graph. Okay, so these are how I'm defining the graph, from plot dot figure to plot dot y label. These are just how I'm visualizing this. I'm doing one more thing. I wanted to see when is the minimum error. Print that also. At least that can be readable, right? So I can see 0.59 is my minimum error. And at what value it is coming? 37. Now see the same in the form of graph. Now see, when I took the value of k is equals to 1, so my error was around 0.70. Similarly, when I'm taking the value of k is equals to 5, my error is around again 0.69 or something like this. Similarly, k value was increasing, my this uh, error was reducing. And you can see k 30 what was that? 37. At 37, my error was minimum. That was 0.59. And again, it started. Let me tell you, it doesn't mean higher the value of k, lower is the error rate. No, not at all. Never. It's never the case. It can, for this particular data set, it happened for this, that at k is equals to 37, my error was minimum at uh, like k is equals to 37, my error was minimum. But that is not the case for every time. It may happen that your error could be minimum at 7 itself, and after that it would have been increasing and increasing and increasing, right? So that is how you have to check. So with the graph you can see at k37 my error was minimum. But this is not the case. You cannot predict that, okay, now error is minimum at 37, let's take the k value of 37. There's another criteria as well, that is accuracy. You have to check that as well. Again, the same thing. I took 1 to 40, the k value, because that is how I'm checking the error rate as well. And again, the same thing. I'm doing the fitting of that, I'm doing the predicting of that, and I'm appending my accuracy. And this again, plot dot figure to plot dot y, it is just plotting. And I wanted to see the maximum accuracy, minimum error rate, maximum accuracy. And I can see my accuracy was maximum at, again, k is equals to 37. So if you'll see the graph, see how my accuracy is increasing. My error was decreasing at all these particular points, and my accuracy is increasing. So at, again, k is equals to 37, my accuracy is 0.41. That is, I can say that if I'm going to use this model, if I'm going to predict a data set, or train the data set, but any kind of, you can remove this data set which I've taken. If you want to take another data set and you want to train at this model, you can take the value of k at 37. Or I should say, if we change the data set, the value of k can also be changed. Okay. So this is the three things today I deal with. One was I took a very small data set which we have created. You can create your own data set. That's just one data set I created taking two different classes. And just two classes were there, right? One was weather and one was temperature. On the basis of that, I predicted a kid can go to play or not. Secondly, I took a some larger data set which were having more number of features, that was height, width, and even more number of classes, that were four classes, right? And we predicted our data, like our KNN on that, and we all even predicted our data by giving some random numbers, and we can see our model is working fine. Third, what we see was how to find the number of k if my data set is really huge. Okay, so what we can do is we can find in the terms of error rate and accuracy. So at whatever k value, my error rate is minimum and my accuracy is maximum. At that particular point, we can find my k value. Okay. So yes, this is what KNN is, and I have taught you K nearest neighbor with the help of sklearn. Sklearn is one library which is very convenient to use. You can directly call your K nearest neighbor. Otherwise, we did a scratch hands-on programming for our neural network. We can do that as well, and even neural network can be called from sklearn. We didn't need to do what we did from in the last class, calculating back propagation, feed forward, everything. We don't need to do that. So that is how sklearn is preferred. So please ask me if you have any doubts. We still have some time, and let me know if you have any doubt.
Hello,
Uh,
ma'am.
yeah, please tell me.
Ma'am, I had a doubt regarding the assignment of eighth, like assignment 8.
Okay,
So there is a question which says that we need to predict the probability that student will not play.
okay,
If you remember the question, so
okay.
uh, but the answers aren't coming right. So do we need to predict the, I mean, guess the likelihood, or do we need to find the probability?
So, okay, first thing, I'm so sorry that I am not the part of the assignment things. So, I really don't know what question it is. If you can
Okay.
elaborate me a little bit more about question, I can help you in that. I can make you understand, because we have time, I can deal with that as well.
Okay,
So
ma'am. So actually, it's a big data set. So
okay,
from that, we need to find out that if a student will play or not,
okay,
given that the outlook is sunny, temperature is
okay,
some,
yeah.
humidity is
Hmm.
something.
Yeah.
So using the knife-based method.
Hmm.
But ma'am, as I was solving, I didn't get the answer for the probability. But I think the question asks about the likelihood.
Yeah. So
So
see, probability and likelihood are almost similar. Probability is something which you are telling, okay, 20% is chance that the child will go to play, 30% chance the child will not go to play, or if there are more than one classes you need to predict. So this is how probability is terms of percentage. What you are telling is maximum likelihood is the is on the basis of different features you are defining that what your sorry, so on the basis of your different features you are defining your the student will go to play or not, right? So what you're telling is, I think, is an example of maximum likelihood. Okay.
yes, ma'am, got it.
Yeah.
So I think the question asked that, but it's a written probability. So yeah. Uh,
See, the probability is always in the terms of percentage, like I would say, but that is not the case, that is not how you do with the question you are telling. What I
okay.
meant is, yeah, if I'll tell it will rain or not, so that you can tell in the terms of probability. 40% chances that it will rain, or 60% chance that it will rain. That is how probability is. Okay. Yeah.
Yeah, got it, ma'am. Thanks.
Yeah. Any more questions? Let me know if any particular topic you want to discuss to me for coding part, because I would like to deal with those questions or those part which you want to have a hands-on training with. Otherwise, like I am going to deal like different algorithm in the coming classes. But yeah, if there any particular algorithm which you want to work, please let me know. Yeah, please
Ma'am,
tell me.
I would like you to, show some ensemble methods in the programming, like
Okay. Yeah,
using
yeah,
some ensemble.
yeah.
If
Definitely,
it,
I'll do that. Definitely, I'll do that. Anyway, that was in my list. So ensemble methods, we are going to work with it.
okay,
Yeah.
thank you.
So in ensemble method, is there any particular topic you want to work with, like bagging, boosting, or any particular topic which you want me to deal with? That is also fine with
Ma'am,
me.
gradient boosting, if you could.
Okay. Yeah. Done. So in the next class, I'll try to do that.
Okay, thank you.
Yeah. Okay. If you guys have no other question, and I'm sorry that I need to cancel yesterday's class. I was traveling somewhere, so I couldn't attend the class. And let me know if you have any other doubt. Otherwise, we'll meet in the next class. Okay, so I'll stop presenting. Okay, then let's meet in the next class. Okay, thank you so much.